Hello guys, welcome to another video on the CCNP security certification, and we are going to configure a GRE with IPSec on it, and we're also going to configure a SVTI um, IPSec site-to-site VPN connection. So let's go ahead and start. So the SVTI is going to be between R1 and R2. We'll go ahead and put SVTI right here, and the GRE tunnel with IPsec on top of it is going to be right here. So let's go ahead and put it at GRE right here. And let's go ahead and start with this configuration. The first one that we're going to configure is going to be the GRE with IPsec. So let's go ahead and start that. And we have to configure the IP addresses because I have not configured any of the IP addresses. Config T, let's also do a host name of R3 for this one. Let's go to interface uh, gigabit 0/0, which is the one pointing to gigabit, which is the one pointing to router 2. The IP address for this one is 40, that 2. Let's do a shutdown. We can go ahead and exit. Now let's go ahead into we actually need to go to R2. Let's go ahead and config T. Let's do a host name of R2. Interface gigabit 00, which is the one pointing to gigabit to router 3. IP address of 40.1.1.1. Now shut down, and now we should be able to ping from R2. We should be able to ping router 3. So do ping 40.1.1.2. There we go. So we're able to access that router. So now let's go ahead and start with this configuration. So the first thing that we want to configure is phase 1 of IKE version 1, aka the ISACamp. So let's go ahead and configure that. The first thing that you need to configure is the crypto ISACamp policy. So let's go ahead and create a policy. We're going to start with R1. So crypto ISACamp policy is going to be policy 1. And from here, you need to do the encryption, the hashing algorithm, the authentication, the group number, and also the lifetime. So let's go ahead and start with that. The encryption is going to be triple dash authentication. We're going to be using a pre-share key. The hashing is going to be 2ND5. The different group number is going to be group number 2, and the lifetime is going to be the maximum one, which is 86,400. Okay, so we have now configured the policy, which is part of the IKE version 1 phase 1. So after we do that, we need to go ahead and configure crypto, ISACamp, and we need to give it a key. And now we can give it a key name, which is going to be CCNP security, and then the address that we want to attach to it. And we want to attach it to our 3 IP address, which is 40.1.1.2. There you go. So that is done. After we have done that, what we need to do is we need to go ahead and configure phase 2 of this tunnel. And phase 2 is to configure the transform set. So let's go ahead and do that. Crypto IPsec transform set, and we're going to call it just T set. Actually, let's just do GRE T set. Looks better. And the encryption is going to be ESP with 3 des. Um, yep, ESP with 3 des, and the hashing is going to be ESP with MD5 and HMAC. And the tunnel mode needs to be, or the mode is going to be tunnel. And after we do that, we need to go ahead and create the interface tunnel 1, and that is going to be where we configure GRE. So let's go to interface tunnel 1, and for here we need to configure the tunnel source, the destination of the tunnel mode, which is going to be GRE IP, and the IP address of this tunnel. Okay, and then after that we need to attach, let's see, no, actually I'm not done with phase 2. I need to go ahead and configure since I'm not configuring a crypto map, I'm going to be configuring a profile. I need to go ahead and create that profile, and then I need to attach that um, transform set to the profile. So let's go ahead and do that real quick. And the way that you do that, you do a crypto IPSec profile, right? Let me see. Yep, crypto IPSec profile. Let's go ahead and get out of here first. Crypto IPsec profile, and the profile name is going to be GRE profile. That's how we're going to call it. And in here, we need to set the transform set, which is going to be called the same name that we gave it to that transform set over here. There we go. So that is done. And now we can go ahead and go into interface tonal 1, and let's go ahead and give it the source of this tonal source, which is coming out of gigabit 01 or gigabit 00. The tonal destination, which is 40.1.1.2, or tonal destination. There we go. And then we need to give it an IP address for this tonal. We're going to create an IP address 60.1.1.1. There we go. And then after we do that, we need to go ahead and configure the tonal protection, which means that we're going to attach IPsec to it, because GRE by itself cannot provide encryption. So we need to go ahead and do that. IPsec profile, and right here we need to attach that profile that we created, which is GRE profile. There we go. So now you can see the ISAC went from on off to on. So ISAC is now on. So now we need to do the same on R3. You can see that the line protocol interface changed to down. So it should come up after I configure on R3. So we need to go ahead and configure phase 1 over here. So we need to create a policy. So crypto ISAC policy. We're going to use policy 1. Let's go ahead and configure authentication, a pre-share key, encryption, which is 3 des, and this needs to match. It needs to match R3 needs to match R2, so hashing MD5. The group number needs to match as well. The lifetime is 86400. Okay, so we have authentication, encryption, hashing, group number, and lifetime. Let me see if I'm missing anything. I am not. So after we do that, we need to go ahead and configure the crypto key. So crypto ISAC camp key TCMP security, it needs to match. And the address for this is going to be 40.1.1.1, which needs to match to this address right here. Okay, so that has been configured, and now we have configured phase 1. So now we need to configure IKE version 1 phase 2, which is configure the transform set and then attach that transform set to the profile that we are going to create. So you do a crypto IPsec transform set. We need to give it a name, GRE tset, sounds good. And we're going to use ESP with 3 des, and ESP with MD5 and HMAC. The mode needs to match to tonal. So now we're going to exit, and then we're going to create a crypto IPsec profile, right? There we go. And now we give it a name, and it's going to be GRE profile. And here we need to set the transform set to the name of this, which is GRE tset. Great. So now we need to go ahead and configure the tonal, GRE tonal. So interface tonal, we're going to use tonal 2. The source is going to be gigabit 00, or actually tonal source, and then tonal destination is going to 40.1.1.1. We need to create an IP address, which is going to be 60.1.1.2, 255.255.255.0. And after we do that, I believe that we need to go ahead and attach that profile that we have created. So we can use IPsec, so tonal protection IPsec profile, and we attach that profile that we created, GRE profile, which has the transform set attached to it. There you go. So now it is on, and as you can see that the protocol was down for the interface, for the tunnel interface, and now it came up. So now if you want to do some show commands, you can go ahead and do a show crypto ISACamp SA and show crypto ISACamp SA, and this is to verify phase one of um, phase one that it is working. You can see that it is active, and you can also, if you want to see um, the phase two, see if phase two is working for IKE version one, you can do a show crypto IPSec SA. I forgot the show. There we go. And as you can see right here, there is 0 packets that has been encrypted, and we can change that real quick by pinging. You can go ahead and ping 40.1.1.1. There we go. And now if we do a show crypto IPSec SA, oop, it is now being encrypted. Let me see, what did I? So from router 2, okay, so from router 2, you want to ping router 3, which is 40.1.1.2, and now we should have something encrypted. It was not encrypted. Interesting. So it looks like it's not working. Let's see a show crypto IPSec SA, show crypto ISACamp SA. You can see that it's active. Let's try to ping 40.1.1.2 again. Okay, so it is working. What if we ping the tonal, which is 60.1.1.2? Able to do that. Now let's go ahead and show crypto ISACamp SA, show crypto IPSec SA. Now you can see that it was encrypted. So whenever we ping, or whenever you use the tonal, you can see that it is going up. So that's how you configure um, GRE with IPSec. But if you want to configure SVTI, and what SVTI does is that it removes the 4-byte packet, which makes this transition, which makes the communication a little bit faster because it is lighter. So we are going to configure SVTI so you can see the difference. It's actually almost identical to it. It is only one command that changes. So let's go ahead and configure that. And that's going to be between R2 and R1. So in R2, we need to configure interface gigabit 01 with an IP address of 30.1.1.1 and then 255.255.255.0. Now shut down. Now let's go ahead to R1, config G. First give it a host name, R1. Interface gigabit 01, IP address of 30.1.1.1 or 1.1.2, 255.255.255.0. Now shut down. Now we should be able to ping 30.1.1.1. We do a do ping. There we go. So we have a connection between R1 and R2. Before we keep going with this configuration, we want to make sure that this interface is active and we're able to ping each other. So now from here, what we need to do is we need to go ahead and configure first phase one for IKE version 1, which is going to be the same. We just need to create it on a different policy. Since we use policy 2 for, since we use policy 1 for this one, we're going to use a different policy for router 2. But for router 1, we can use crypto policy 1. So let's go ahead and crypto ISACamp policy. We're going to use, let's just use like 50. And from here, authentication is going to be a pre-share key that we're going to be using. Encryption, we're going to use 3-des. Hashing, it's going to be ND5. Group number, it's going to be group number 2. Lifetime is going to be the maximum, 86,400. So then after that, we need to go ahead and create a crypto ISACamp key. We're going to call it CCMP security as well. and it's going to go to address of 30.1.1.1, right? We configure router 1. So we need to send it to router 2 right here, 30.1.1.1. Great. So after that is created, we are done with phase 1. That's phase 1 of IKE version 1. So we now need to create a transform set and a profile, and then a tunnel. So let's go ahead and create that transform set first. And to do that, you need to do a crypto IPSec transform set, and we are going to call this SVTI set for transform set, and we need to give it an ESP of um, 3 des, and then ESP for the hashing. It's going to be ND5 with HMAC. The mode is going to be tunnel mode. Great. So now we need to go ahead and create the interface tunnel, and we're going to use tunnel 3. And from here, we need to do the tunnel source, which is GRE01, tunnel destination, which is going to be 30.1.1.1. And then we need to create a IP address for this GRE tunnel, which is going to be, let's go ahead and create just 50.1.1.1, or .2 actually, 255.255.255.0. Great. So now after we do that, we need to go ahead and do a tunnel protection using IPSec profile. And the profile that we're going to be using is, I did not create that profile. So let's go ahead and create that profile first. Exit. Let's do a crypto IPSec profile. The profile is going to be called SVTI profile. And we're just going to add the transform set, which we call SVTI set. We can just copy it from here, paste it. And now let's go ahead into the tunnel 3, and we need to do the tunnel protection using IPSec profile, and we're going to use this SVTI profile. There we go. So now the command that changes is going to be the tunnel mode. So tunnel mode, I did not do it for R2 and R1, R2 and R3 because um, the default is to use GRE. So when you want to use SVTI, you want to change that mode to be um, tunnel mode, use IPSec, and we're going to use IPv4 for that. Okay, so that is done. So we are done configuring R1. Now we need to go ahead and configure R2, which is basically doing the same thing. So we're going to create a crypto ISACAM policy. We're going to use policy 50. We're going to use the authentication of a pre-share key, encryption, 3 des, hashing, ND5, and this needs to match group number 2. So router 2 needs to match router 1, or otherwise it won't work. The lifetime needs to be 86,400. Now let's go ahead and create a crypto ISACAM, ISACAM key, CCMP key, security. The address that needs to match is 30.1.1.2. Oops, let's go ahead and config T. So that is done. So now we're done with phase 1. Now let's go ahead and configure phase 2, which is crypto IPSec transform set. We're going to call this SVTI set. And we need to add the encryption, which is 3 des, and the hashing, which is ND5 with HMAC. The mode is going to be tunnel. Now we need to go ahead and create the profile. And the way you do that is crypto IPSec profile. And we're going to call this SVTI profile. And we're going to set the transform set over here. And it's going to be SVTI transform set. Okay, now let's go ahead and do an interface tunnel Let's go ahead and say tunnel 50. The tunnel source is going to be gigabit 01. Tunnel destination has to be 30.1.1.2, the IP address of router 1. After we do that, let's go ahead and do the tunnel mode, which is going to be an IPSec with IPv4, and that's what tells this tunnel to use SVTI configuration, right? And that drops a GRE 4-byte packet. So after we do that, then we need to do a tunnel protection IPsec profile, and we need to attach that profile. Boom, that's done. So now you can see that it was down and now it came up, and you can see right here that it also came up in router 1. So now from here, let's do some show command, show crypto isocamp SA. And you can see that it is active for 30.1.1.2. You can also do a show crypto IPsec SA for phase 2. And we should have, this is for tunnel 1. This is the one going to 40.1.1.2, which is this one right here. But we want to see the other one, right? We want to see tunnel 50, okay, which is going to 30.1.1.2. Let's see if we are able to do SA tunnel 50 or SA. Let's do interface gigabit 01. Let's say peer. Okay, so SA peer 30.1.1.2. There we go. So now we can see it like that, which is a lot better. And after we do that, I also want to do, because SVTI supports dynamic routing. So let's go ahead and create a couple of interfaces, and then we are going to enable EIGRP. So let's go ahead and configure interface. We're going to create a loopback one with an IP address of this router 2. So let's do 2.2.2.2. Exit router EIGRP 1. The network that we need to add 2 networks, which is the loopback address, and we also need to add the tunnel. And let's see if we do a do show interface tunnel 50 and tunnel 50 IP address. See if we can find it. Do show IP interface tunnel 50. Do show IP do show IP do show IP interface brief. Let's just go ahead and do interface brief. And this tunnel is 60.1.1.1. So let's do network 60.1.1.1. Done. Now let's do it on our one. Let's configure interface loopback of 1 with an IP address of 1.1.1.1. Let's go ahead and configure router EIGRP. Remember that EIGRP needs to match the autonomous system the autonomous number, the same as this router 2. So we can form an adjacency. So let's go ahead and add this network 1.1.1.1, and let's do a do show IP interface brief. And the tunnel for this one is 50.1.1.2. Show IP interface brief See if I configure this right. Okay, so ton of 50 does not have an IP address yet. So we need to change that and make it 50.1.1.1 for router 1. So interface tunnel 50 IP address 50.1.1.1. And now let's go ahead into RGP1 and let's go ahead and remove this network because we don't need it. And let's go ahead and add 50.1. Let's see. Wait, did I do this right? So on router 2, do show IP interface brief. Let's try it again. So 50.1.1.1 and 50.1.1.2. Okay, so that's good. So now on router 2, we are going to add the other network, which is 50.1.1.2. There we go. And now you can see that we have a new adjacency. So that is great. Show routes, show IP route, ERGRP neighbors, or ERGRP. You can see that we have that right here. So that is working good. So now we can do, let's try to, from router 1, let's try to ping 2.2.2.2, which is a loopback address. It was ping. Now let's do a show crypto IPSec SA or SA, and the peer is going to be 30.1.1.1. And you can see that there's a lot of more packets here because we're using ERGRP, and ERGRP, I think, I cannot remember from my routing and switching times, but I think it's like every 5 seconds it sends a new packet, and that's why we see how it's incrementing, how it is encapsulating and decapsulating a lot more. But we are able to ping and we are able to do all that good stuff. Let's see if we are able to do a show crypto. Um, let's see, show crypto route sessions engine. No, we don't want to do that. Identity, um, IPSec, maybe IPSec profiles. And you can see that on router 1 we have 2 profiles, which is the default one, and we also have the SVTI one that we created. Let's see how many we have on router 2. On router 2 we should be able to have 3, which is the default, the SVTI one, and the GRE one. So show crypto IPSec profile. And like I said before, we should have 3, the GRE profile, the one that goes over here, the SVTI, the one that goes to router 1, and the default one that comes with it. So this is the one that you cannot delete, and it comes with the router. Okay, so you can see both of them are working. So we have configured SVTI, IPSec VPN tunnel, and we also created a GRE tunnel. So that's how you are able to configure both of them. Um, a lot of companies use SVTI more than GRE because GRE adds a 4-byte packet to the header and makes this the data to go a little bit slower than SVTI. And SVTI makes it faster because it removes the 4-byte GRE packets from the header. So this is it for this video, guys. I hope you guys enjoyed this video. And if you guys enjoy this video, why don't you just go ahead and follow me on Twitter at, let's go to my profile at CCNA Daily Tips if you have a Twitter account. And if you don't have a Twitter account, you can go ahead and create a Twitter account and then follow me on Twitter. So thank you guys for watching. I love you guys, and I'll see you on the next one. Bye bye.